The principle is discharge, control of current, and then production of light. Cold weather makes it difficult for the arcing to happen because without arcing in fluorescent tubes, there is no lighting. This is Electrical Awareness, and welcome to this YouTube channel. My name is Jeroboam Kimtai, and I greet you out there. And with the love of God, I thank God because of preparing us to talk today on electrical awareness. We are talking about electrical lamps. And before we continue, I welcome you to join me by subscribing, liking, and sharing, so that when we share to a wider range of people, for many people to learn about this. So, welcome. Many people out there do not know how to choose which kind of lamps to use. When we talk about lamps, others call them lights or lighting. And so we have a lot of people and quite a number who do not know how to choose. They rely on electricians to choose for them. They may not know the need of that customer who wants to install some kinds of lamps. Otherwise, you are welcome, and greetings from my friend David Otieno. He is with us. Now, what are lamps? A lamp is a device that converts electrical energy to lighting energy. This one converts electrical energy to light energy. We have had a variety of lamps since inception. When electricity came into play, we have had a lot of transitions from one kind of a lamp to another kind of a lamp, one kind of a lighting system to another kind of a lighting system. So I'll do an example of like three. We have had incandescent lamps. People call them ordinary bulbs. Incandescent bulbs use this kind of lighting as a lighting principle of incandescence. Incandescence is production of light via what we call elevation of temperature. So for the incandescent lamp to give out light, there must be a rise in temperature. That is its principle. And then the filament inside the lamp glows up after a rise of temperature. We have another kind of lamp which is called LED, light emitting diodes. Okay, this principle is by electricity passing through a semiconductor. A semiconductor is this LED kind of lights. And so these are one of the lights that is low voltage and low current emitting kind of lights. Another one is fluorescent, which we are going to dwell on today. Fluorescent lighting, fluorescent lamp, and we'll talk about fluorescent tube, fluorescent starter, fluorescent choke, or a choke ballast. As we began, I said and told you that a lamp is a device that converts electrical energy to lighting energy. So in every kind of lamp, be it incandescent, be it LED, or the fluorescent we are talking about, there must be a principle and a process by which light is produced. Fluorescent lamp. A fluorescent lamp or a fluorescent tube depends on electrical discharge. The electrical discharge is produced in the electrical fitting of the electrical fluorescent fitting. And this electrical fluorescent fitting has the choke ballast inside, it has the starter, it has the fluorescent tube, and of course the housing, the fitting. So those are the four major components that wires are run through. Now, electrical discharge is by the starter. when electrical discharge has come out, there is an electrical producing component in both ends of the of the fluorescent tube. These electron discharge devices are the ones that will produce the electrons. After the discharge has been struck, this produces the electrons. These electrons run through the tube, and in the tube there's a mercury ions. Mercury ions are inside there, or argon, but mostly it is a mercury. So this mercury collides with the electrons. After these electrons collide, we form the ultraviolet radiation. Ultraviolet radiation is formed due to the ionization of the mercury atoms. So these mercury atoms, all the components I'm talking about, are inside the fluorescent tube. So ultraviolet ions, or ultraviolet radiation rather, are not visible. So what happens? We have the fluorescent coating, and I know this is where the name comes from. We have the fluorescent coating on the walls of the tube. These ones convert the ultraviolet radiation into visible light. So basically, that is how a fluorescent tube is supposed to work. Okay. Now, what is the work of the starter and what is the work of the choke ballast? We begin by the starter. The tube, for it to produce electrons, the 240 volts is not enough for the discharge to happen. And so the starter strikes an arc. This arc is an arc of up to close or thereabout 900 volts. These 900 volts are enough to make the electrons flow from one end to the other end of the tube. Now, this will be able to help in the discharge, enough discharge. So, with the normal 240 volts as a nominal voltage, it is not able to make the current to travel through very well. So we need the arcing, and this arcing is supposed to be high voltage arcing. So that is the work of the starter. When the starter is turned on, the arc is struck, and thereby in a very small fraction of seconds, we have 240 volts getting converted into 900 volts of voltage, and this will be enough to carry the arc of the current through the tube, and therefore having this colliding with the mercury ions. And when the mercury ions are struck with an arc, we get the atoms of mercury now producing ultraviolet radiation. Okay, and ultraviolet radiation now will be converted into light by the fluorescent coating around the tube. That is inside the tube. The inside of the tube is coated with the fluorescent coating. Now, the choke ballast. The current needs to be controlled once the arc has been struck, because this high current is not good. It may cause the tube even to explode, to shatter, because it is glass-like. It has a material like glass, and so the current has to be controlled for it not to shatter. After the arc has helped in the lighting of the tube, then it has to be controlled immediately, and that is the work of the choke ballast. To control the current into normal conditions, favorable levels for the light to be there without shattering the tube. That is basically what happens in the process of lighting. And then when we want to do the lighting, remember normal wiring, we have the neutral, we have the live, and the earth. Okay, the neutral and the live complete the circuit. But the earth since most of the fluorescent fitting is metallic, so we need to have a safe return in case of an eventuality. And this is the work of the earth wire. The earth wire is fixed on the body of the fluorescent fitting. Yes. And so as we continue, remember to subscribe, to share, to like, and watch. Just watch, because this thing is very important. I began by saying most of the people do not know do not know how to choose which lighting system and when. And they don't know, they don't have parameters with which they are guided on how to choose one lamp or one lighting system over the other. And so that is why I am able to run I'm able to run you through these lighting systems that we are talking through. Back to the fluorescent fitting and the fluorescent lighting generally, we have situations where fluorescent lighting do not light immediately. We have a lot of blinking, and sometimes it can even fail not to light. And so there's a reason for this. Several reasons, but I'll talk about one today. One of them is when there's cold weather makes it difficult for the arcing to happen, because without arcing in fluorescent tubes, there's no lighting. And so cold weather is an enemy, if I would say, for the arcing. So now you know that when it rains, and you know this, when it rains, it is very difficult for the fluorescent tube to work. And so the reason is because of the difficulty in arcing, in production of discharge, production of discharge by the starter. Now you know. And so that has been our part today to share. And with this, immediately I will introduce what we call compact discharge lamps. Compact discharge lamps are the normal bulbs we've been using, or the lamps we've been using, the ones that are coiled, maybe round coiled or U-coiled, or we call 2D. Those have been compact, but they use the same principle as the fluorescent fitting. The principle is discharge, control of current, and then production of light. So discharge, current control, and production of light, or conversion of ultraviolet radiation into visible lights. Otherwise, thank you for watching. I also take this time to thank those that have been watching this channel on electrical awareness, and I take this opportunity to invite those that have not subscribed to this channel to subscribe. This is a way of helping me to reach many people out there. Thank you. Bye.